Okay, we're going to finish up this recording. So right now we're doing um, the H12B. That is the next part of the H12A, H12B handout. So the last part of this video that we're about to do is the example problems that you see right here. Okay, question A. Find the magnitude of the components of vector 1, 4, parallel and perpendicular to vector uh, uh, this one here. So the first thing that we need to remember is if it's parallel, then I need to do A dot B divided by the magnitude of B. So for parallel, we're going to do A dot B divided by the magnitude of B. Okay? And we can say A is equal to 1, 4, and B is equal to negative 1, 2. Okay. Understanding which one is A and B is going to be really important for problems 2 and 3 after we do this. Okay, so let's get started. A dot B is equal to 1 times negative 1 plus 4 times 2. Okay, which gives us negative 1 plus 8, which gives us 7. Okay, and now we need to do the magnitude of B, which is equal to the square root of negative 1 squared plus 2 squared, which gives me 1 squared is 1, 2 squared is 4, so the square root of 1 plus 4, which is the square root of 5. Okay, so now I've got what I need to get parallel. So if I have A dot B over the magnitude here, that's going to give me 7 divided by square root of 5. And if I plug that into my calculator, 7 divided by square root of 5, we get 3.13. So this is the component of the vector parallel. This is the component of vector parallel. Okay, so now we need, so if it's perpendicular, then we're going to use this formula here when it's perpendicular. So when we're dealing with perpendicular, we're going to do A cross B, and then the absolute value of that, which is the magnitude of A cross B, divided by the magnitude of B, which we already have. So let's figure out what A cross B is first. So A cross B, the cross product of that is, so we got 1, 4 cross negative 1, 2, which gives me 1 times 2 minus 4 times negative 1, which gives me 1 oh, wait. 4 times negative 1. So, okay, let's do some arithmetic. So that gives me 2 plus 4, which gives me 6. Okay. So And now I need the magnitude of that. So the magnitude of A cross B is equal to the square root of no, it's not. What am I doing? Okay. So it's absolute value, not magnitude. So we've got A cross B over magnitude of B. So we just figured out A cross B is equal to 6. Magnitude of B, we know, is square root of 5. And so if I do square root of 6 divided by 5, we get 2.68. So this is the component of the vector perpendicular. Okay, hit pause if you need to. All right, now we're going to do the other page. Okay, we got the magnitude with this component parallel and perpendicular to this plane here. Okay, so if it's parallel, we know it's going to use this formula, right? So we need to figure out 205 dot 2, 2, negative 1, which gives me 2 times 2 plus 0 times 2 plus 5 times negative 1, which simplifies to 4 plus 0 plus negative 5, which is negative 1. Okay. And now I need to find the magnitude of defined by the two vectors to this one here. So I need to figure out the magnitude of vector B. This is vector A. This is vector B. Okay. So we need to find the magnitude of vector B because we want to plug it into here. So the magnitude of vector B is going to be the magnitude of 2, 2, negative 1, which is the square root of 2 squared plus 2 squared plus negative 1 squared. 2 squared is 4, plus 4 plus 1 gives me the square root of 9, which of course is 3. Okay, so now I have what I have. So A dot B over the magnitude of B for parallel is going to give me negative 1 divided by 3, which is negative 0.333, repeating. That is my component to the vector parallel. Okay, perpendicular. Okay, so for perpendicular, I need the cross product of A cross B. Okay, so A cross B, that gives me 205 cross 2, 2, negative 1, right? Okay, that's equal to 0 times negative 1 minus 5 times 2, then 5 times 0 to 0. And then for the middle one, it's 5 times 2 minus 2 times negative 1. And then the last one, 2 times 2 minus 0 times 2. Okay, that simplifies to negative 10. 10 plus 2 is 12, and 4. Okay, so now we need to find the magnitude of this. So the magnitude of negative 10, 12, 4 is going to give me 10 squared plus 12 squared plus 4 squared. Okay, so that's 100 plus 144 plus 16. 100 plus 144 plus 16 gives me 260. Square root of 260 is approximately 16.12. Okay, so for perpendicular vectors, the component of the vector perpendicular, we use A cross B divided by the magnitude of B. So this is going to be A cross B is 16.12, right? The magnitude of B we found up was 3 up here. So this divided by that. So that answer divided by 3 gives me 5.37. So this is the component to the vector perpendicular. Okay. Now, the next page, I personally had a lot of difficulty because I was confused on which one was vector A and which one was vector B. And once I figured out which one was vector A and which one was vector B, then it was smooth sailing. So with that in mind, let's read this very carefully. Two forces are pulling on a truck with a mass of 150 kilograms along the rail. The direction of the rail is this, and the two forces are this. So we've got the force of the truck rail and the force pulling on the truck. Okay, those are the two forces. Two forces are pulling on the truck along the rail. The direction of the rail is this. So my rail force is 12, 5, and 0. The two forces that are pulling on the truck are 16, 8, and 2. And the other one is 18, 10, and 5. Okay, so the first thing I need to do is to figure out the resultant force. Okay, so the resultant force pulling on the truck is equal to adding these together, which is, if I add those together, I get 34, 18, 7. Okay, so these are my two vectors. The force, two forces pulling on the track. The direction of this is the force of the rail. This is the force on the track. Find the component of the result force in the direction of the rail. Okay, so thinking about here, the component of A in the direction of B. The component of A in the direction of B. The component of the resulting force, that's A, in the direction of the rail, that is B. One more time. The component of the resultant force, which is A, in the direction of the rail, which is vector B. Okay, so now that I know A and B, so we just said the rail. This is vector B. Force pulling on the rail, this is vector A. Okay, so find the component of in the direction of. So that means parallel, not perpendicular. So because we're dealing with parallel, we're going to use A dot B divided by the magnitude. Okay, so let's figure out what A dot B is. So A dot B is equal to 34, 18, 7 dot 12, 5, and 0. And so that gives us 34 times 12 plus 18 times 5 plus 7 times 0. And if I calculate that, I get that is equal to 498. Okay, now I need to figure out the magnitude of B. And we just said B is the resulting force pulling on the truck. No. B is the force of the truck rail. See, I had made the mistake. I took the magnitude of this one instead of that one, and then I got all scared. Woo! So, okay, so B is this one here. So we're going to take the magnitude of 12, 5, and 0. Okay, so the magnitude of 12, 5, and 0, 12 squared plus 5 squared plus 0 squared, simplifies to 169. And the nice thing about that is that's equal to 13. So now I can figure out the component of the resulting force in the direction of the rail. So I'm going to use A dot B divided by the magnitude of B, which is 498 divided by 13, and that gives me 38.3 newtons. And this is the component in the direction of the rail. Okay, part B. Acceleration of a body is equal to the resultant force divided by the mass of the body. Okay. Resultant force divided by the mass of the body. Okay, find the acceleration of the truck along the rail, assuming no other forces are. Okay, so the so along the rail. So along the rail is my parallel parallel force, this guy here. So this is equal to 338.3 newtons. My mass is 150 kilograms. Whoa, 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 I messed it up. Oops, sorry. 150 divided by what the heck? Divided by right, is equal to the resultant force divided by the mass. So it should be the mass over the resultant force. Okay. This is the answer. I don't know what I just did wrong. Oh well, we'll figure that one out. But the other, we'll come back to that one. Okay. Last question. Okay. In still water, a boat can travel 8 kilometers on full speed. On a certain day, the boat is traveling in this direction on full power. A current is flowing with a speed of 10 kilometers per hour in the direction of this. Find the velocity of the current as the column vector. Okay. So the velocity of the current is a column vector. So we know it's going in this direction. In the x direction it's going 3, in the y direction it's going 4, and we want to figure out this angle. Okay. So in order to figure out the angle, we know it's opposite, we know it's adjacent. I'm just going to write this here as a reference. Okay, so opposite and adjacent, I'm going to use tangent. Tangent theta equals 4 over 3. And using my calculator, I figure out that this is 53.1 degrees. Okay. So now I want to figure out the velocity in a column as a column vector. So in the x direction, I'm just going to draw the two triangles. We know this is 53.1 degrees. We know this is 10 because that's the speed. So in the x direction it's there. So we've got the hypotenuse, we've got the adjacent. So if I've got hypotenuse and adjacent, I'm going to use cosine. So I can write cosine 53.1 is equal to adjacent over hypotenuse, x over 10. So now I know my x value can be represented as 10 cosine 53.1. Now in the y direction, we've got same triangle. I'm going to write y there, 53.1. And we know that's 10. So this is opposite, this is the hypotenuse. So opposite hypotenuse, I know I'm going to use sine. So sine 53.1 equals opposite over hypotenuse, y over 10. Cross multiply, I know y can be represented as 10 sine 53.1. Okay, so now I want to write this as the velocity of the current as a column vector. So the velocity of the current as a column vector is equal to 10 cosine 53.1 and then 10 sine 53.1. And if I plug in 10 cosine 53.1, we end up with 6, and here we end up with 8. Okay, next. So this is our velocity of the current in column form. Okay. Question B says, find the component of the current acting in the direction of the boat is traveling. Okay, so in the direction, okay, that means parallel, right? Okay, so if it's parallel, then we know we're going to be doing A dot B over the magnitude of B. So we need to figure that out. Okay, so first we need to figure out a column vector for the direction of the boat. So for the boat, we know the boat is going 8 kilometers, and it's going to the right 1, and it goes up 1. Okay, so we know if it's a triangle like this, it's going to be 45 degrees, right? So just like what we did over here in the x direction, if that's 8, that's 45. We could write this as, okay, this is adjacent, so I can write this as cosine 45 equals x over 8. So x is equal to 8 cosine 45. In the y direction, we know we've got opposite and the hypotenuse, so we're going to use sine 45 equals y over 8. So we know y is equal to 8 sine 45. So my boat vector is equal to 8 cosine 45, 8 sine 45, which simplifies to 5.66, 5.66. Okay. So now I've got my two vectors. Now we can finally do some work. Okay. So find the component of the current that is acting in the direction of the boat is traveling. So the component of the current, the component of A. So this is saying A is the current. A equals current. Okay. Find the component of the current acting in the direction of the boat, in the direction of B. So B is equal to the boat. This process is so important. Oh my gosh. Okay, so I need to figure out the magnitude of B and the dot product of the two guys, and then we're good. So A dot B is equal to 68 dot 5.66, 5.66. Okay, and then so that gives me where's my boat work? 6 times 5.66 plus 8 times 5.66, and that gets me 79.2. That's my dot product. Okay, now the magnitude of B is equal to the square root of 5.66 squared plus 5.66 squared, and this gives us, what does that give us? Square root of that, and let's just call that 8. Okay, so this is equal to 8. So now I can say A dot B over the magnitude of that gives me 79.2 divided by 8. And we get, that's 79.2 divided by 8 gets me 9.90 kilometers per hour. And this is the component of the current acting in the direction of the boat is traveling.